So in the previous video, we looked at the application of the counting principle where we were told that repetition is allowed. Now I want us to look at the application of the counting principle where repetition is not allowed in this case. So we are going to continue with our example of creating a 4-digit code given 10 digits, which goes from 0 to 9. But in this case now, we are not allowed to repeat any digits. This means that a code like 0, 0, 0, 0 is no longer allowed. A code like 1, 2, 1, 1, 2, 3 is no longer allowed. But what we are interested in finding is now a code something like 1, 2, 3, 4, like that, or 2, 5, 6, 8. Now there is no repetition. You can see that each number or each digit appears only once in the code, right? So this is the code that we are trying to create. Now let's create our set as we have previously done. We create a set containing all the digits that we are given, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right. So what we are going to do here, we are going to put our code over here. So these will be the numbers that we choose in each step. Right. So this is the code. Here we want to put down the number of possible ways or the number of possible choices that we have in each step, right, by each selection. So let's call this choices or options that we have, right? So let's start in the set. So we first start by counting how many choices do we have. That means how many elements do we have in the set. We count the number of elements. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements in total, and we are going to put that in our choices. Right. Once we have done that, we go ahead and choose. Let's say we choose the number 4. Once we choose a number, we cancel it out because we cannot have it for a choice in the next selection step. All right. Meaning we are eliminating it from the set. Right, so we are going to write 4 in our code. Right, now let's recreate the set now without 4 because we have eliminated 4. So our set now is going to look like 0, 1, 2, 3, 4 is no longer there. We have 5, 6, 7, 8, and 9. Right, how many choices do we have now? We have 1, 2, 3, 4, 5, 6, 7, 8, 9 choices. So we are going to write down the number of choices that we have. Let's say we choose number 7 for our code. Each time we select the number, we cancel it out from our set. It gets eliminated. So it goes into the code now. Alright, now let's recreate our set again, now excluding 7 because we have selected it. Right. We have a set containing 0, 1, 2, 3, 5, 6, 8, and 9. Right, let's count how many choices do we have. We have 1, 2, 3, 4, 5, 6, 7, 8. Right, we have 8 choices. Now let's make a choice. Let's choose 3. We cancel 3 out because it has been selected. Right, now we go ahead and recreate our set. We have 0, 1, 2, 3 is eliminated, 5, 6, 8, and 9. Right, let's count. How many choices do we have? We have 1, 2, 3, 4, 5, 6, 7. 7 choices. Right, now let's go ahead. Let's choose a number to put into our code. Let's choose 2. We cancel it out and we put it into our code. Right, let's recreate a new set now. we have 0, 1, 2 is excluded, 5, 6, 8, and 9. Right, now we see that our boxes where we have to fill the code is filled. Right, that means we have satisfied the number of digits that are needed for the code. We have 4 digits, so this is our code. So how many possible ways do we have of creating this 4-digit code given these 10 numbers? So the total number of ways, or the total possible ways of creating this 4-digit code, is simple multiplying all these choices together as we have done in the previous examples. Right, so we have 10 times 9 times 8 times 7, which will total to 5,040 possible ways of creating this 4-digit code. All right, now it is important to note that we are not only restricted to having numbers or digits, we can have letters. Right, as a matter of fact, let's look at an example where we have letters and we have to arrange. Right, now with letters, can we have repetition? Can we? Well, it's possible, because now think of the word even. It's possible to have a repetition here because we would repeat E, but in this case repetition is not allowed. So I want us to look at an example whereby we do not have any repeating or identical letters to make this example easy. Right, in this case, how can we arrange the letters in the word action? How many ways can we arrange these letters? And we are told that repetition is not allowed. So in this case, it's going to be very easy, because you simply take the total number of ways, the total number of letters that you have in the word, and you keep on decreasing it by 1 in each selection. So what do I mean? Let me take you through. This is what it means. We have, how many letters do we have in the word action? We have 1, 2, 3, 4, 5, 6. So we are going to create 6 spaces. We have 1, 2, 3, 4, 5, 6 spaces created. So I say to you, you are going to take the total number of letters. Why? That's because there is no repetition of any letters, or there is no identical letters present in the word action. It will be different if we had any identical letters or repeating letters. Right. So you are going to take a total number of letters in the word action and decrease it by 1 in each step. So here we have 6 letters. So we have 6. We decrease 6 by 1 until we reach 1. Let's go. We have 6 times 5 times 4 times 3 times 2 times 1. And we are done. And this is the total possible ways that we can arrange the letters in the word action. And the total of this would be 720 possible ways of arranging the letters in the word action. And this we give a special name. We call it a pure arrangement. And whenever you have pure arrangements, what you need to do is simple. Take the total number of letters that you have and compute a factorial. So a factorial is represented by the symbol, but that symbol is called factorial in mathematics, and you can find it in your calculator. And whenever you press a number and then this symbol, so what is going to happen is, let's say you take 4 factorial. So what your calculator is going to do is going to take this 4 and multiply it by, reduce it by 1 and multiply it by the next number. Reduce 3 by 1, multiply it by the next number. Reduce 2 by 1, multiply it by the next number. So this is what the factorial means. So whenever you have a pure arrangement, like in this case, what you would do, you count the total number of letters in this word and compute a factorial. So in this case, we had 6 letters in total, and we can see that this is a pure arrangement. So what we need to do, which you could have done rather than doing this, is you take the total number of letters in the word action and compute a factorial, and this would give you 720. Right, so that's it for this video, and please do watch the next video where we are going to look at some more example where we are looking at arrangement with restrictions.